So let's start in section 2.1 talking about parallel lines and special angles created by parallel lines and perpendicular lines. Okay, so perpendicular lines, let's go over some theorems. From a point not on a given line, there is exactly one line perpendicular to the given point. And perpendicular lines meet at 90-degree angles or at right angles. So if I have this line and this point here, P, that is not on my line, there are not an infinite number of lines that I can draw that are perpendicular. There's only one that will go through P. And this can be a line, this can be a ray, this could actually be a plane, but there's only one. So here we have some pictures of, here's line M and line L, and they're perpendicular, and the little box notation tells us that that's a 90-degree angle. Here we have a line that is perpendicular to a plane. Here we have two planes that are perpendicular to each other. All right, so lines or planes or rays have an end point and then go off with an arrow on the other end, can be perpendicular. So just as the word perpendicular can relate to lines and planes, we have the word parallel, which can also be used to describe a relationship between lines, rays, and planes. Parallel lines in the same plane will never intersect. Of course, in the same plane means like two lines drawn on a single sheet of paper, or two lines that you would draw on a wall. Parallel lines will never intersect. They have no points of intersection. So here we have line R and line S are parallel. And here I'll write this a little bigger. Line R and line S are parallel. And the intersection of R and S is the empty set. There's no point in common to both lines. Here we have a line R and a plane T. Planes have uppercase letters, so line R is parallel to plane T. And the line and the plane have no points in common. And here we have two planes that are parallel. They will never intersect. So here I have two parallel planes. I have plane M and plane N. They're parallel, but I have a third plane, G, that intersects them both. All right, so here's the line of intersection of plane M and plane G intersect at line A. Plane N and plane G intersect at line B. What do you think we would know about line A and line B there then? They're on the same plane. Each line is in a parallel plane, so not surprisingly, line A would be parallel to line B. And hopefully you can kind of see that by the drawing that we made. So in Euclidean geometry, by a mathematician named Euclid, named after a mathematician named Euclid, we interpret a plane as a flat, two-dimensional surface like a piece of paper. It's got a length and it's got a width. and the line segment that joins any 2 points on the plane must be on the plane. All right, so here we have a diagram down here. Let's make sure we're just getting used to reading all of this now. Here is plane R. R is a plane. It's like a piece of paper. It's a flat two-dimensional item. Here is line M. And there can be points on the line. And here is point P. P is a point. So any points on this line have to be in the same plane. If they're on the same line in the plane, they have to be on the same plane. But through a point not on the line, just like there is one and only one parallel, a perpendicular line that can be drawn, that's what we started this lecture with, there is one and only one parallel line that can be drawn. I'll call that line K. Line K would be parallel to line M. I couldn't draw more than one line that would be both through point P and parallel to M.